In this problem, we need to prove that f sub k is equal to 3 times f sub k minus 3 plus 2 times f sub k minus 4 for all integers where k is greater than or equal to 4. So the way to start this proof is to start with the definition of f sub k. So what is it that we know about f sub k? Well, f sub k, because this is the Fibonacci sequence, is equal to f sub k minus 1 plus f sub k minus 2 for all integers k is greater than or equal to 2. So next, what I want to do is I need to kind of move backwards in the Fibonacci sequence because I need for my final answer to have f sub k minus 3 and f sub k minus 4, and I don't have either of those right now. I have a k minus 1 and a k minus 2. So how to deal with this? Well, what do we know about f sub k minus 1? Obviously, this is going to need to turn into something with k minus 3 and k minus 4 in it ultimately, and the same thing for k minus 2. All right, so according to the Fibonacci sequence, any term, right, so we know this from here, any term is equal to the previous term. So now, if my term is f sub k minus 1, then the previous term is f sub k minus 2. And we add that to the term before that. Aha. So now, what comes before k minus 2? K minus 3. There you go. Now, this is going to be so for all integers greater than or equal to 3. Because keep in mind that we can't have k being less than 3, right? Because then we'd have f sub negative 1. We don't go into the negatives on there. We can have f sub 0, f sub 1, and all that. But we can't go below 0 on that subscript. Okay, so that helped with k minus 1. But what about f sub k minus 2? So I still have that here in the original equation, and I have one here as well. So I really need to find out what that's equal to. And I'm going to do exactly the same thing again. Well, not exactly. Pretty much the same thing again. Slightly different. So we've got f sub k minus 2. What comes before that? K minus 3, f sub k minus 3. Plus, and then what comes before that is f sub k minus 4. Okay, so now what I can do is for my original equation, and we know that f sub k is equal to f sub k minus 1 plus f sub k minus 2, so I need to add these two together. So that's going to give me f sub k minus 2 plus f sub k minus 3 plus f sub k minus 3 plus f sub k minus 4. Now, and I skip this, for all integers k is greater than or equal to 4, so that's going to be the case here as well. For all integers k is greater than or equal to 4. So now we've got that piece of it, where k has to be greater than or equal to 4. And I need to lose this f sub k minus 2 right here. So I'm going to plug in this. And now I have f sub k equals f sub k minus 3 plus f sub k minus 4 plus f sub k minus 3 plus f sub k minus 3. And I'm just leaving the terms the way they are. I'm not adding them together just yet. And then I'll do that for one big dramatic finish. Okay, so then this equals 3 times f sub k minus 3 plus 2 times f sub k minus 4. And again, that's for all integers k is greater than or equal to 4. And that is what we wanted to prove. So QED, quota rot demonstrandum, and we're done.